Hey guys, we're going to do a little lesson here on 3.4 slopes of lines. We're going to explore slope in terms of a rate of change. We're also going to look to see how that relates to the equation of a line, and also we're going to talk about parallel perpendicular lines and their relationships compared to their slopes. So first, 3.4, we're going to look at the four possibilities when it comes to describing a slope. The first is sometimes when a slope is positive. So if we have a positive slope, as I move from left to right, I'm going to move from down to up. So again, anything that's going to follow that pattern, that would be a positive slope. A negative slope, as I move left to right, is going to move down. So negative slopes are going to look something like this. No slope, or also called zero slope, is when as I move from left to right, it doesn't move up or down. So anytime I have a horizontal line, that's a line with zero slope. Sometimes you've heard of this called kind of HOI. HOI is a little acronym or short for horizontal line, zero slope, y equals a number. So we have a positive slope, we have a negative slope, we also have a zero slope. We're going to use the word HOI to kind of remember that. And then the last type of slope we could have is an undefined slope, or any type of vertical line. So no slope meant as I move left to right, my slope is zero. Here, I'm not moving left to right, I'm moving vertically, up or down. So here, any type of line that's moving vertically. And a little acronym we're going to remember for undefined slope is VUX, V-U-X. HOI, VUX. HOI, horizontal line, zero slope, y equals a number. Y equals a number because it's crossing through the y-axis. VUX, vertical line, undefined slope, and it crosses the x-axis, so x equals a number. Alright, so with that in mind, we're also going to kind of look at the type of equation of a line that we use in geometry, and that type of equation of a line is called the Slope-Intercept Form. So this is one of the forms you learned back in Algebra 1, and this lesson is a lot of repeating of what you learned back in Algebra 1, with a few twists, especially when we talked about parallel and perpendicular lines. So because this y equals mx plus b is slope-intercept form, the variables m and b represent specific characteristics of the line. So m represents the slope of a line, and the b represents the y-intercept. Or, if you're not familiar with that terminology, it's where the line crosses the y-axis. Now, two ways we can help us find slope, because slope is a calculation, or it's a rate of change. If I wanted to find slope, or the m, I can use the formula, which means I'm going to take the change in the y values over the change in the x values. Or, in other terms, if I had 2 points along my curve, or along my line, I would do y1 minus y2 all over x1 minus x2. Another way to kind of explain that is this process called stack and subtract. So if you like to follow kind of little acronyms or little sayings, that might help you in terms of finding slope as well. Alright, so let's do a couple examples. Remember, whenever you're following along with one of my videos, if you feel like you're understanding it and you get it, feel free to pause, try the problem on your own, and then pick up where I left off. So hopefully you paused a little bit and tried this problem. First thing I'm going to do is I'm going to try number 1 with the formula. If I'm trying to find the slope of the line between those 2 points, I'm going to label x1, y1, x2, y2, and I'm going to go ahead and m, my slope, is equal to the quotient of y1 minus y2 all over x1 minus x2. Be careful with your signs. -4 minus 2, taking away 2 from a -4 takes me to a -6, and taking away 5 from 2 leaves me with a -3. A negative divided by a negative is always positive, so my slope for number 1 is 2. Now, Mr. Ausel, what's this whole stack and subtract thing? Well, let's look at the 2 points, and let's stack them on top of each other. So I'm going to bring -1, -2 down underneath, -1, 3. Now that I've stacked them, I'm going to subtract. So -1 minus a negative, which is really plus, becomes 0. 3 minus -2 plus means 5. And since I stacked my x's and I stacked my y's, slope is the change of y over the change of x. So the change of the y's was 5. The change of the x's was 0. Now, is it possible to divide 5 by 0? Let's think about it this way. Could I take 5 pizzas and divide them 0 ways? That doesn't make any sense. And if you put this into your calculator, you're going to get an error message. That's because you cannot divide any number by 0. So because that is true, this slope is undefined. Undefined. So let me just repeat that one more time. Whenever your x's are the same value, you're going to get a denominator of 0, and therefore you have undefined slope, which should make sense because everything in the vertical line, or undefined slopes, all have the same x's, and their y's are all different. Alright? Go ahead and try the third one, see how you do, and then you can check in with me. Let's use the formula here, so we'll do y and y. We'll do -1 minus a -1 all over x and x, -6 minus 3. So my numerator becomes 0, my denominator becomes -9, and any number, 0 divided by any number is always 0. So this has a 0 slope. So now that we know how to find the slope between 2 points and understand the relationship of the 4 different types of slopes, let's talk about another relationship that two lines can have when comparing their slopes. So the first is, if the slopes of 2 different lines are parallel, then I know the slopes of the 2 lines that are parallel are the same slope, or they're equal to each other. If the slopes of 2 lines that are perpendicular, their slopes are going to be opposite reciprocals. Opposite reciprocals. And maybe you've talked about this or not, but remember, opposite reciprocals means that I'm going to take a number, for example, like 2, and I'm going to change it to a -1/2. I'm going to take a number like 3 and change it to a -1/3. What if I had like a -4? Well, then it would become a 1/4. Or if I had, for example, a 1/5, that would go to, a 1/5 would go to -5. So quickly you can kind of recognize the pattern that we're doing. We're taking the reciprocal of the number and then making it positive or negative. So let's look at a couple examples here together. Again, anytime you can always pause, try it out, and then follow along with me. So what is the slope of a line that's parallel to the given line? So if this is in slope-intercept form, y equals mx plus b, the m would be equal to 2/3. And because the slopes of parallel lines are the same, I'm going to stay with those 2/3. But what if I wanted to find the slope of the line perpendicular? If the given slope was 2/3, what I'm going to do is I'm going to do the opposite reciprocal, which means I'm going to flip and take the reciprocal 2/3, which we know is 3/2, and then we're going to take it from positive to negative. So my new slope is -3/2. Now looking at our problem number 5, we're given an equation that's in standard form and not slope-intercept form. So before I can identify the slope, what I need to do is I need to solve this equation for y. To do that, I'm going to subtract non-y terms to the other side. I'm left with, I'm going to erase some of this so I have some more space. I'm going to end up with a -2y is equal to -4x plus 9. Then I'm going to divide by -2. Remember, dividing to all the terms in my equation. So my y is equal to -4 divided by -2 is +2. 9 divided by -2 is -4.5, or we can leave that as -9/2. So if I'm worried about the slope, slope is always the m and y equals mx plus b. So here, a parallel line would have the same slope of 2. If I wanted to find a perpendicular slope, I would take 2. 2 can also be rewritten as 2 over 1. I reciprocate that, so that becomes 1 over 2. And since it was positive, it's going to become negative. Alright, let's turn to the next page. And let's kind of determine if line 1 and line 2 are parallel, perpendicular, or neither. Mainly looking for, are the slopes the same, or are they opposite reciprocals? If they fit one of those relationships, then I know that they're parallel, perpendicular. If it's neither of those relationships, then it's neither. Go ahead and pause the video at this time and see if you can try the problems on your own. Alright, so the first thing I'm going to do here with my red pen is I'm going to go ahead and find the slopes. I'm going to look at the x's, I'm going to look at the y's. I'm going to take the difference of the y's, so y1 minus y2 minus a negative is plus, divided by x1 minus x2, 2, and then here 12 plus 5 is going to give me 17, and 8 minus 7 is 1. So the slope of line 1 is 17. Here in my blue pen, I'm going to find the slope of line 2. So I'm going to take the change in the y's, so 3 minus 2, all over negative 9 minus 8. 3 minus 2 is going to be 1. Negative 9 minus negative 8 is negative 17. So when I look at the slopes here, I'm going to highlight my slopes. I got negative 1/17 and I got positive 17. These two numbers are opposite reciprocals. So because they're opposite reciprocals, I can go ahead and state that they're going to be, line 1 is perpendicular to line 2. Line 1 is perpendicular, that's the symbol for perpendicular, is perpendicular to line 2. Cool. Go ahead and try number 7, and again, you can always pause and then fast forward depending on how you do on the problem. So I'm going to look at the x's, I'm going to look at the y's, take the difference of the y's, 4 minus a negative 4, which is really plus, all over negative 1 minus 3. So I get an 8 over negative 4, which reduces down to negative 2. And then also I'm going to look at my second line with a different color, and I'm going to end up with difference of the y's, 7 minus 1, all over 2 minus 5. Remember, you want to be consistent, so like here, the 2 and the 7, they're stacked on top of each other. The 5 and the 1 are stacked on top of each other. So as long as you see those vertical alignments, you know you're putting them in the right spots. Alright, 7 minus 1 is 6, 2 minus 5 is a negative 3, and 6 divided by negative 3 is negative 2. So now the slopes are the same, and since the slopes are the same, then we know that these two lines are parallel. Line 1 is parallel to line 2. Using my notation there. Alright, we're going to look at number 8 here together, and then there's going to be a couple, the last example here for 3.4. So we're going to write the slope-intercept form equation for a line that passes through the point 1,4 and is parallel to the line y equals negative 4x plus 5. So if I'm trying to find the equation of the line, the first thing is the line that I'm trying to find has to pass through the point 1,4. So it's got to go through this point right here. Now, to figure out how I'm going to draw that line, I need to first understand how its relationship is to the given line that they gave me. So here is a line in slope-intercept form. And when I look at this, if I know that this line is parallel to the line I'm trying to find, that means their slopes have to be the same. So the slope of this given line was negative 4, so the slope of my line has to be negative 4. Now, what I know about my line is that the slope's negative 4, and it passes through the point 1,4, which is an ordered pair that I can graph on my graph here, which is including an x value and a y value. So if I go back to my original slope-intercept equation, if the slope is -4, that's m, so I'm going to plug that in for m. If x is equal to 1, then I'm going to plug that in for x. And if y is equal to 4, I'm going to plug that in for y. What I've just done is I've kind of plugged in the variables I know, and it isolates the variable I still need to find. So I'm going to solve this equation. -4 times 1 is -4. When I add 4 to both sides, I get b is equal to 8. So what this is telling me is the y-intercept is going through the point 0, 8, because that's my y-intercept. So up here at 0, 8, and if I'm going to go down slope down 1, 2, 3, 4, 1, 1, 2, 3, 4, 1, I'm going to get an equation of a line that goes through this right here. Okay? So my final answer is y equals the slope, -4, x plus +8. Alright, so that's a little lesson on slope, and specifically talking about the relationship between parallel and perpendicular lines.